Okay, take a next question. Same, the next question is also calculate the collapse load for the beam shown. So this is a beam. So this is a beam. ABC is a continuous beam. So in that, when the span AB, the point load is placed exactly at the center at D, and in the span BC, again the point load is upward, which is placed at E, which is exactly at the center. So now in this case, calculate the collapse load. Now what is the first step in the calculation of collapse load? So the first step in the calculation of collapse load is finding out the DS. So what is the DS? Come on, tell me everyone. So how to find out the DS? Once think. So it's very simple. Seeing the number of reactions at the supports and considering the number of equations of equilibrium. So upon subtracting the number of reactions minus number of equations of equilibrium, we are going to get DS. So what is the DS in this case? So load is vertical, whether it may be upward or downward. Simply the load is vertical. So here one reaction, here another reaction, here another reaction. So how many reactions? 3 reactions. And how many equations of equilibrium? Only 2. No need to consider sigma x equal to 0. There is no horizontal load. Minus 2. So 1. Agree. How many plastic hinges? 1 plus 1, 2. So 2 plastic hinges are required for the formation of mechanism. But locations? So where the plastic hinges can form? Locations are possible locations. Where it can form? C. Under the point load, we know it. So it means at D and at E, the plastic hinge can form. And one more thing, see. At B also, the plastic hinge can form. The reason, see, if this hinge support is at, hinge or roller support is at ends, then it is already a hinge. It cannot take any moment. So that is the reason if you observe in strength of materials, okay, I guess in strength of materials you have studied that concept. So in drawing the SFD and BMD, we have considered the bending moment at simple supports. That is either at hinge support or roller support is 0. But the very same support is in the span, in between the span, then the bending moment is not 0. The summation of moment may be 0, but there acts some bending moment, which is hogging. So always at supports, hogging moment will act. So here that B, it can take bending moment. So it is considered as a fixed support or rigid joint, not as a hinge support. The reason it is a continuous. Clear? So here it can develop some bending moment. So now possible locations for the formation of plastic hinges is D, B, and E. So these are the possible locations. But for the formation of mechanism, we require only 2 plastic hinges. So again, going for the possibility. So first possibility. So assume hinge at D and B. So consider only this part. So this is like a proper cantilever beam with center point load. Agree or not? Tell me. See why? Because this continuous beam, the supports in the continuous beam act like a fixed support. Why? Because they can take the moment. Okay, they can take the moment. Of course, the moment summation of total moment at that joint may be 0. At that support may be 0, continuous support. But they can take bending moment. So we can assume it as, or we can idealize the span AD as a proper cantilever beam with center point loads. Come on, tell me. What is the collapse load for the proper cantilever beam with center point load? That is why I said. So that is why I said that all these standard cases are very, very important. So if you remember the standard cases, no need for the calculation here. Agree or not? So tell me, what is the collapse load for center point load, proper cantilever beam with center point load? So for a proper cantilever beam with center point load, the collapse load is 6 MP by L. Agree or not? So here hinges are going to form at D under the point load and at B. That is the case. And if we consider BC, so BC is also nothing but the same case. Proper cantilever beam is center point load, but it is upward. But whatever may be the direction of the load, it is simply same case. Okay. Similarly, for plastic hinge set, EB. The collapse load is 6 MP by L. Why? Because that is also the same proper cantilever beam. Now the third possibility. So these are the two possibilities. The next possibility, hinges at D and E. Okay, the next possibility, so at D comma E. So first possibility is at DB, second is BE, now the third is DE. So assume the hinges at D and E. So now assume the hinges at DE. So after forming the hinges at D and E, how the beam deflects? So this is a beam here, so it will break here. So it will rotate like this, and this is the span, so it will rotate like this. So now how the deflected shape? So this is the deflected shape. So here the point load, here the point load W. So this is L by 2 and this is L by 2. So L by 2, L by 2. So W. A, B, C. And this is D and this is E. So now we know that if this is theta, and here also it is theta because of symmetry, and here also this is theta, and here also this is theta. So now external work is equal to internal work. So what is external work? External work is done by these two forces, that loads W and W. So this is delta. So it means DD dash. So this is DD dash and this is EE dash. So we know that DD dash and EE dash are same. EE dash is equal to DD dash is equal to L by 2 theta. Now external work. So external work is, so the work done by this load and this load. So how much? W L by 2 theta plus W L by 2 theta is equal to internal work. So wherever the plastic hinges is formed, there MP will develop. So here the plastic hinge is formed. So now here that plastic moment will make this theta 0 and this theta 0. Indeed also same case. So total how much? MP theta plus theta plus MP theta plus theta. So how much finally? How much here it is simply W L theta. And here it is 4 MP theta. So now theta will get cancelled. So finally, how much MP? Collapse load W is equal to 4 MP by L. Now which is true collapse load? So which is true collapse load? In which case we got the less value or least value, that is considered as a true collapse load. So obviously this is a true collapse load.